All right, hello everybody. So today we are going to continue our discussion in Chapter 8, Section 5. And if you watched the last couple of videos, what I showed you was how to find the GCF as well as for numeric values, like as you see in front of you, 6 and 15, for instance. And then I also went through and showed you how to find the GCF of algebraic terms as well as algebraic expressions like this that you see number 6. So now what we're going to do is to use that skill of finding the GCF to actually do what is called factoring. And if you recall, I have previously said that factoring is the reverse of the distributive property. So if you remember how you distributed terms together and then combined all your like terms, factoring is the opposite of that. We're going to take out terms. In this case, we are going to take out the GCF. So let's talk about how to do that. So in this first expression, number 6, which is a problem that we've already done in a previous video, finding the GCF, we found the GCF to be 10x. And so now what we want to do is actually take that 10x out of this expression that we have right here, this 20x squared minus 30x. So to do that, the first thing we will do is we will write a 10x on the outside and then put a set of parentheses. And now we simply need to divide both of these terms by 10x. And so when we do 20 divided by 10, we end up with a 2. And when we have x squared divided by x, we get x. The next part is there's a minus right here. So we will put a minus right here in the middle. And then once again, we have a division problem. We have 30x divided by 10x. So 30 divided by 10 is 3. And then x divided by x is 1. It goes away, so there is no more. So what you have left now, after we divided both of the terms in our algebraic expression by the greatest common factor, we got 2x minus 3. Now, how do we know this is factored? Well, the way that you can check to see that you did this correctly is to redistribute the GCF. So if I took this 10x and I multiplied by 2x, I would end up with 20x squared. And then if I took this 10x and I multiplied by negative 3, I would end up with negative 30x. And what you can see is it matches perfectly with what we started with, 20x squared minus 30x. So let me erase a tiny bit. We'll get rid of these arrows here because we've already distributed. This is our factored answer. We factored out the GCF 10x and we were left with 2x minus 3. So we're going to do the same thing for the next one. You can see right here we have 10r to the third minus 5. And in a previous video, we found that the GCF was 5. So now what we will do is we will begin by writing the GCF down, followed by a set of parentheses. Now we're going to take our original expression and divide every term by the GCF. In this case, just 5. So we are left with right here, 10 divided by 5, which gives me 2, and then we have an r to the third power. And then we have 5 divided by 5, which is 1. You can see these two things were separated by a minus. So our final answer down here will also have a minus in it. And there you go. That is the factored form. If I did want to check, I could take this 5 and redistribute it. When I do that, I get 10r to the third minus 5. And that matches perfectly with what we started with. So there's our final answer. So let's try a couple more. We have this one here. And again, we have already previously found the GCF. The GCF of this expression is 5y to the second power. So in order to factor this, we will start by writing the GCF, 5y to the second, followed by a set of parentheses, just like the last two. Once we've written the GCF and a set of parentheses, we can divide both terms by the GCF, 5y squared. Now, 5 divided by 5 is 1, and y to the fourth divided by y squared is y to the second. You can see there's a plus, so we will put a plus down there. And lastly, we have 5 divided by 5, which is also 1. Then we have y squared divided by y squared, which is also 1. So we will write a 1 right there. And that's it. We're done. This is the factored form. Remember, just like in the previous problems, if you want to check that your answer was done correctly, you can take this GCF on the outside and multiply it back through the set of parentheses. In this case, we would have 5y to the fourth plus 5y squared. And that matches what we started with. So we're all done. There is your factored form. Okay, here's another one. We have an expression 24x minus 48y. And once again, we have already found the GCF. In this case, the GCF was 24. So we will start by writing the GCF, followed by a set of parentheses. Then we'll take our original expression and divide both parts of that expression by the GCF, which is 24. 24 divided by 24 is 1, so we are only left with a 1x. 48y divided by 24 is 2y. These are separated by a minus, so this will be separated by a minus. And we're all done. There is the factored form of the original expression. So moving on to a few more problems. They will be done just like the last couple that we've done. We have 21a to the fifth minus 15a to the first. Now, once again, we start by writing the GCF. We have already found it. It was 3a. And once we have written the 3a, we will write a set of parentheses. Now, inside that parentheses, we will write what we get when we divide both of the terms in our expression by the GCF. So we have 21a to the fifth divided by 3a to the first. 21 divided by 3 is 7, and a to the fifth divided by a to the first. In case you forget this, I probably should remind you, we subtract. So it becomes a to the fourth. So this becomes 7a to the fourth power. Now there's a minus here, so we put a minus right there. And then we have 15a to the first divided by 3a to the first. 15 divided by 3 is 5. And a to the first divided by a to the first is 1. So we don't need that. So what you can see now we're left with, this is the factored form. 3a times the quantity 7a to the fourth minus 5. So last one, it's going to be done just like all the other ones. We will start by writing the GCF, 2c, then put a pair of parentheses, and dividing both terms by our GCF, 2c. First one is 14c to the second divided by 2c to the first. 14 divided by 2 is 7. C to the second divided by c to the first is c to the first. Next, we have 2c to the first divided by 2c to the first. So the 2's cancel, the c's cancel, and we're just left with a 1. They are separated by a plus, so we'll bring that plus down. And there's your final answer. Now, you don't need to have c to the first there. You can just leave it as c. If you put the 1, that's fine too. It doesn't matter. Either way is okay. All right, now we're going to move into a little bit harder one. And it's harder because there are multiple terms in this one. You can see we have a 12xy we have plus 24y squared, then minus 36x squared y to the fourth. So the procedure is still the same no matter what as far as how we factor these. The first thing we do is write the GCF and then put a set of parentheses. The next thing we are going to do is we are going to divide each one of these by the GCF. Now, when we divided those, you can see the first term, we have to deal with these each individually. 12 divided by 12 is 1. X divided by X is 1. And Y divided by Y is also 1. So all of that just turns into a 1. Then we have a plus. And now the next one, we have 24xy to the second divided by 12xy. So 24 divided by 12 is 2. X divided by x is 1. Those cancel out. And then we have y to the second divided by y, which gives us y to the first. You can write y to the first, or you can just write y. It's perfectly fine. Now you can see we have a minus, so we will put a minus right here. And lastly, we're going to divide the last term. 36 divided by 12 is 3. X squared divided by x is x to the first, right? This one cancels and one of those cancels. And then we have y to the fourth divided by y to the first. Again, as a reminder, y to the fourth divided by y to the first, you would subtract 4 minus 1, which is y to the third, like that. Okay, so we have 3xy to the third. There is our final answer. If you did want to check it, you could take this and remultiply it to each term, and you would get what we started with. Okay? Okay, 2 more. So once again, we'll start with the original expression, and we will write the GCF first, followed by pretty good sized set of parentheses, so we have enough room to write everything. Once we've written the GCF in a set of parentheses, you will divide each term by the GCF. Once we've divided each term by the GCF, we can write out what we're left with right here. So let's do that. We have 55 divided by 11. That turns into 5. Then we have p squared divided by p squared. That's just 1, so we don't need to write the 1 there. It would be 5 times 1, but we'll just leave it as 5. Then we have 11 divided by 11, which is 1. Oh, almost forgot. We have a minus right here, so we'll put a minus. Then we have 11 divided by 11. And then we have p to the fourth divided by p to the second, which gives us p to the second. Now, lastly, we have 44. There's a plus. Then we have 44 divided by 11, which is 4. We have p to the fifth divided by p to the second. That gives me p to the third. And there's our final answer. 11p squared times the quantity 5 minus p squared plus 4p to the third. Now the last one we will do is this expression right here. You can see that we had already found the GCF. It was 4t. So we start by writing the GCF, followed by a set of parentheses. Then we divide each one of these by the 4t. So 4t divided by 4t is 1. So we can just put a 1. Everything cancels. Then we have a plus. Then we have 12 divided by 4, which is 3. And t squared divided by t would be t. Lastly, we have 16 divided by 4, which is 4. And t to the third divided by t to the first is t to the second. And there you go. There's your final answer. So I hope this video made sense. As always, if you have any questions, feel free to email me. Have a great day.